It gave Spider-Man his web, Godzilla his stomp. In the real world, radiation gives us powers more super than monstrous, but many fear it as an invisible menace. In today's video, we shed light on one type of radiation none of us can avoid, and use it in an easy hack that could potentially save your life. Radiation is a catch-all term left over from the 19th century before we knew much about physics. It comes from the Latin radiare, meaning to gleam, shine, or beam, like rays of sunshine. But as scientists investigated the workings of matter and energy, it came to be used to name not just the act of beaming across space, but the content of the beam as well. Today, the word radiation is applied equally to various types of nuclear emissions and to all types of electromagnetic emissions, although these are very different things. Nuclear radiation is a topic for another video. Today we're discussing electromagnetic radiation and whether your microwave popcorn will give you cancer. Scientists originally saw electricity and magnetism as two different things, but today we know they're two different aspects of the same fundamental force of nature. This force comes in discrete measurable units called photons, and depending on how you measure it, can appear to act as waves or as particles. The truth is, it's neither. It just is what it is. And to avoid turning this video into an hour-long digression on quantum mechanics, it's probably best to just remember that the terms particle and wave are somewhat metaphorical, even though their effects are very real. Electromagnetic radiation comes in a continuous spectrum of wavelengths and energy levels, which we've divided up and named. What we call light is a tiny little bit in the middle that we are evolved to see. At the low end of the spectrum are microwaves and radio, and at the high end, X-rays and gamma rays. We all know X-rays and gamma rays can be dangerous, but how exactly? Electromagnetic energy affects matter by interacting with the electric charge of electrons. When a photon encounters the electrons surrounding an atom, it can either pass on through, be absorbed, or be reflected. If it's absorbed, it can excite the atom, converting its electric energy to vibrational or thermal energy. This is how the sun heats the earth. If it has enough energy, however, it can knock an electron loose from the atom, and since all chemical bonds are between the outermost electrons of atoms, this can break the bonds that hold an atom to its neighbors. This is why fabrics fade when exposed to sunlight. When an atom loses an electron this way, it's left with a positive charge and is called an ion. For this reason, radiation that can do this is called ionizing radiation. This is the kind that's potentially harmful because it can break chemical bonds, and we're made out of chemicals. Gamma ray photons and X-ray photons have enough oomph to overcome the binding energy of electrons bound to an atom. A single photon of either can, in principle, break a DNA molecule in the wrong place and give you cancer. Photons of any frequency from light all the way down to radio can't, not even close. If you absorb enough radio or microwave energy, it will slowly heat you up. That's how microwave ovens work. But that's not magic voodoo heat. It's not any different than the heat from an open flame. It can't break chemical bonds, so it can't give you cancer or turn your lasagna into frankenfood. But higher on the spectrum, lower than X-rays but above visible light on the energy scale, there is a bit of gray area, so to speak. Ultraviolet light, so called because it's the color right above that which we can see, sits right at the transition point between ionizing and non-ionizing electromagnetic radiation. And it's subdivided into three subparts: A, B, and C. UVA is just barely ionizing. It's needed by the body to make vitamin D, but also ages the skin, causes sunburn, and increases the risk of cancer. UVB has higher energy and seriously increases damage to the skin and cancer risk. UVC is fully ionizing. If it's absorbed by a molecule, whether in the air, skin, or protoplasm, it will destroy it. The sun produces a wide range of frequencies of light, including UV. Fortunately for us, all the UVC is filtered out in the upper atmosphere, along with most of the UVB and some of the UVA. That's a good thing, too. If unfiltered sunlight could reach the surface, the UVC light would destroy all exposed microbes, kill the leaves of most plants, and burn the skin and corneas of animals like us. But like other types of radiation, UVC isn't magic death cooties. If we understand and control it, it gives us terrific superpowers. UVC light is used around the world to sterilize surgical tools, purify water, clean hospital air, and even cure some types of epoxy, among other things. It saves countless lives, and now that COVID-19 is sweeping the land, there's been a huge surge in interest in UV sterilizers for personal use. The good news is UV sterilization can be an effective and helpful part of your pandemic survival kit. The bad news is almost all of the inexpensive battery-operated sterilizer wands that look so attractive in online ads are worthless. They either don't emit UVC light at all, or are so feeble the battery would go dead before you finish doing the job. To sterilize surfaces or the air, you need a UVC light source bright enough to inactivate virus in a reasonable amount of time. Laboratory sterilization cabinets use UV bulbs that work just like fluorescent lights, but without the phosphor coating to convert UV light to visible light. These bulbs are bright enough to destroy viruses, bacteria, and fungi from a meter away in something like 15 minutes. But light follows the inverse square law. So when applied from a couple of inches away, the exposure time drops to only seconds, perfect for sterilizing a carton of eggs or the mask you wore to the DMV. Handheld sterilizers with that much power are expensive and hard to come by, but fortunately you can make your own. I built mine using a $30 shop light, a pair of 9-watt UVC sterilizer bulbs, and some aluminum HVAC tape. Links in the description. All it really took was replacing the bulbs and removing the plastic bezel meant to protect them, as the plastic would absorb most of the UV light. I also removed the wire bulb guard, both to avoid casting shadows and because the UV light might degrade the chrome plating and cause it to corrode into toxic dust. The aluminum tape conforms easily to all the nooks and crannies inside the light housing and helps protect the plastic from UV damage and prevent any light leaks. With 18 watts of illumination, I calculated my sterilizer would take only 3 to 5 seconds to kill most surface pathogens. But to put it to the test without breaking the bank on a UV dosimeter, I employed the old science fair standby, the Petri dish. Of course, I can't grow virus and wouldn't want to, but viruses are smaller and more vulnerable than most bacteria and fungi, so I inoculated 4 quadrants of the Petri dish with samples from my gums and exposed each for either 0, 3, 6, or 9 seconds to my UVC lamp. The results speak for themselves. After several days in a nice warm place, not a single organism survived even 3 seconds of close-range UVC light. The UV sterilizer is great whenever you have something that can't be easily washed or wiped down, that you don't want to put chemical disinfectants on, and that you can't just leave sitting for long enough for the virus to deteriorate on its own. I use mine before putting eggs, bagged produce, or cartons of ice cream away. Just remember, UVC light can break chemical bonds, including those in your furnishings, skin, and eyes. Whenever you use the sterilizer, always wear UVC-rated goggles, keep pets and other people away, and protect your skin with gloves and long-sleeve clothing. And if you ever go to a party with really good blacklight decor, use caution. Black lights are specially made to emit light right at the boundary between visible and UVA light that appears dark to our eyes but activates fluorescent dyes. UV bulbs would make fantastic black lights if they were not emitting dangerous ionizing radiation. In a couple of cases, partygoers have received corneal burns when UVC lights were used by party planners who didn't know any better. Like other forms of radiation, UV light can be dangerous, but when used wisely, it can be fun, useful, and even life-saving. As always, the key to attaining superpowers lies in understanding. If you like this video, please go ahead and hit the like button. And if you haven't already, subscribe and hit the notification bell so you won't miss any of the science goodness. And if you want more of my science and science fiction, you can support my writing on patreon.com or buy my sci-themed merchandise at teespring.com. You can also find me on Amazon and audible.com.